Okay. So I think the last time that we met, we talked about the vectors. And Tristan should have given you an exercise, which I just saw, but I didn't pick it up. So hopefully everybody came on Wednesday. I don't think we met on Friday, but everybody was here on Wednesday, and you were able to do that little quick in-class assignment. All right? Damn, I ain't got no chalk. I hate this chalk. All right, I guess I gotta use it today. All right, so today what we're gonna do is we're gonna continue, right? Get a little bit more practice because vectors, I told you, traditionally vectors, folks have had difficulty with vectors, particularly if they have trouble with trigonometry in high school or whatever it was, advanced math, those different type of things, right? All right, so in this case, all right, we've been dealing with, so far, I should say, we've been dealing with one vector, at least your in-class assignment was only one vector, and you broke that one vector into its components, and you dealt with it that way. But that was one vector, right? Well, what about when we have three vectors, right? And let's say that these three vectors, right? Let's say that this is some particle at the center, at the origin, right? And it's experiencing forces with magnitude and what? Direction in three different directions, all at the same time. Okay? So it experiences force in this direction, right? And let's call this force, so this is force A, okay? And it has 60 newtons, and it is in a direction of what? Let's say 45 degrees, right? In the what? Northeast, right? From the x-axis, right? Then we have another force, force B. It has a magnitude of 30 newtons, right? And its direction is 37 degrees in the northwest, okay? 37 degrees in the northwest, meaning it's what? 37 degrees with respect to the negative x-axis. All right? Y'all following me on that? All right, so this is north, this is south, east, and west. Right? Now, what if it had another force on it which goes straight down? And we call that force C. And it has a magnitude of let's say 10 newtons, and it's directly in the what? South direction. So if it's directly in the south direction, then that means its angle is what? Not 180, but 270. Right? So south really just means what? Angle equals 270. want to know, well, in what direction and what magnitude does my particle experience force when it's undergoing all of these forces at the same time? So what does that mean? That means I have to add the forces, which are V word vectors. So in order for me to get a resultant force, I remember that? Right? Because that's what it is. It's a result of what? Force A, force B, and force C at the same time. My resultant force, which is also a vector, has, right, plus B plus C, right? Make sure I'm still recording. Yeah. All right. So, so we said in order to get the resultant force, we need what? Force A plus force B plus force C. And we know that the resultant force has what? Every vector has what? Two components. So our resultant force has a what? Force R sub X, which is a component, right? And what? Force in the Y, right? And so we know that what? Force R of X is what? Force A in the X plus what? Force B in the X plus force C in the X. Same is true for force R in the Y, right? F of A in the Y plus F of B in the Y plus F of C in the Y. See that? Okay, so then what we're going to do is we're going to take each individual force or each individual vector and break it into what? Its components. So force A has what? X and Y. Oh, did I give you your, I never gave you your test back? Yeah, I got it downstairs. Has X and Y component, right? So, how do we get the X and the Y component on force A? First, let's look, how do we identify the X and the Y component on force A? Where is force A? This is force A, right? Okay? And what are the components? What are they? Tell me what they are. Give me a definition of what component is. What does it tell you?
Where in the direction?
It tells us how far along each direction. Right? So, how do I identify the Y component of force A? What is the Y component of force A? It identifies how long the vector goes in that direction. I need y'all to understand that. That is critical for understanding. Not for mathematics, it's for physics. Because if you understand that, this is easy. So if you don't understand that, say, I don't understand what you mean.
So wouldn't the Y be the opposite of the angle if you're doing like?
So hold up, let's answer the question first. How do I identify the Y component of the force A?
You see the vector that's going along the Y-axis?
Yes. Right? Which is this, right?
Yeah.
That is the y component of force A. It's that simple. But if you don't recognize that, this is very hard for some people. Okay? So obviously, where's the x component of force A?
Along the x-axis.
Okay, that would be right here, right? Because this right here is the same as, yes. Just like this right here is the same as this right here. I just drew the dotted lines so you can easily see it. Okay? And so, since we know the angle, 45, then opposite of 45 degrees is what? What trigonometric identity is opposite? No.
Opposite over adjacent?
That-
Or opposite over hypotenuse?
Huh?
Two opposites.
I said, hold up, listen at me. Listen to what I'm saying. All right? I said, which trigonometric identity uses opposite? Right? The sine. Right? Sine. SOHCAHTOA, right? SOHCAHTOA. Right? That's sine opposite hypotenuse, cosine opposite, adjacent hypotenuse, and tangent opposite adjacent. All right, so sine. Right? So sine of 45 degrees is, right, well, 60, which is the magnitude of force A, right? So my what? My y component, f of a y, which I was writing over here, right? It's gonna get messy right there, but I can still identify it, right? This right here is my what? F of a y. Here is my what? F of a x. And how do I get those values? Right? I take the magnitude, right? Because I know that what? F of x component is equal to the magnitude, right? And what? Cosine of theta. And my y, in this case, is what? Opposite, right? So that's what? F of sine theta. Y'all following that? Following it? My y component is opposite of my angle. Opposite of my angle. My x component is adjacent to my angle. Right? So now I can plug in the numbers. My x component is what? 60 times cosine of 45 degrees. My y component is what? 60 times sine of 45 degrees, right? And because it's 45 degrees, they're both going to be equal, right? Because 45 degrees cuts 90 degrees into half. Okay? So now we got our components. F of x, f of ax, and f of ay. What are they? Where your calculators at? And you should be in degrees. For which one?
X.
32 point,
42.
huh?
42.4.
42.
0.4.
All right. And what else?
This is the same. Yeah.
Oh, it's the other thing, that's right. 42.4, right? So now, so we got those, okay? We're running out of real estate here, so we'll have to erase some. So we're gonna erase this, y'all wrote it down. if you missed something, then you can go back and watch the video, alright? Where we at? Oh, f of b, right? F of b sub x. F of b has a what? F of b sub x and a what? F of b sub y. What is it? How do we get that one? So we gotta deal with, so our x component is here, and our y component is here, right?
Sine, 37 sine, wait, 30 times sine 37.
Okay, that's the y component, right?
Yes.
So 30, so f of b, well, it's up there already, 30, sine 37 degrees, right? And then our x is what? 30 cosine 37 degrees, all right? Now, what we need to do here is just make sure that we recognize that this vector is in which quadrant?
2.
And we know our x is what in negative. So your x component is negative, okay?
So that's like once you get the actual.
Yeah, once you get the actual number. That's like, so instead of using 137, if you use what? 180 minus 37, you're gonna get the negative number. You following that? Cause this is the angle, that would be the angle right there. You see that?
So both of them would be negative in the third?
In the third, yes. In the third quadrant, yes. So what are the numbers here?
Negative 23.96.
For which one?
X.
Negative 23, 23 point what?
96.
96, and
18.05.
18 what?
0.05.
0.05, all right? So now, all right, so we got that, everybody got that? All right, so now, let's do C. All right, f of C, you got an x and a y, okay? What's the x component of C? 0, great. Does not move along the x direction at all. So what's that y component of C? 10. Nope, no cosine, nothing. Well, you can use the cosine, but that's just gonna be what? 1. Cosine of, right? And it's either, right? It's either it's cosine or sine, I don't know which one it is, of 270 degrees is 1. But it's gonna be 10 though, it's gonna be the magnitude, right? And that just tells you how far it goes in the y direction.
And since it's along the y-axis, the negative.
It's gonna be negative, good observation. Because it's going down. Okay? Great. So now we got all the components for each vector. Now we can do what? Go back and plug them right here. That's it. Right? So to get the x component of our resultant vector, we said what? We needed to add f of Rx is equal to what? F of Ax plus f of Bx plus f of Cx. And so what are those? 42.40 what? 3 plus negative 23.96. Hate this chart. 0.96 plus 0. Now we get our what? Resultant vector y. 42.43 plus
18.05.
oh, it's 18.05
That's negative 10.
plus negative 10. Alright? So, I guess I should have wrote that. And I could erase this now, right? Y'all got this?
Yeah.
Okay. So here, what would it be? 20 something? 19?
18.44.
18.44.
47.
And this one is 47?
No, the 18.44.
Oh, 47. Okay. And what's this?
50.45.
50 point what?
45.
45. Okay. So, now we have a resultant vector, right? And that resultant vector has a magnitude. Well, it doesn't have a magnitude. We can write out, it does have a magnitude. We haven't solved for that yet. What we have solved for is the resultant vector in terms of x and y, right? So we have what? X is 18.47. And remember, every vector has a what? X and a y. Right?
Yes.
So that's our resultant vector. And we can get the magnitude by doing what? Huh?
Tangent?
No. Magnitude. What is magnitude? Come on, y'all. We gotta have this. We gotta get this. Pythagorean theorem. Right? We cannot
The square root, and you square them and then put the square root.
yes. Right? We can't confuse that. Okay? Right? 18.47. Squared plus 50.45 squared. What's the number?
I got 53.7. About the same thing.
53.7? Oh, 53.7. 0.7. Okay? And now, how do we find direction?
Tangent.
Inverse tangent, right? So it would be what? Theta is equal to what? Tangent inverse y over x. Y is 50.45 and x is 18.47. Right? So what's the angle? What's the angle? We got it?
60, 70. You round it up. 69.9 or 70 degrees.
Okay. Everybody got that same number? Or we got something different? 69.9 degrees? Anybody got anything different?
That's the same thing.
The same thing. All right. So, what was the name of that method we just used? Because we have two methods for the component method. So now, we're going to look at what? The tail to tip method. Right? But with the same vectors. Okay? Okay? And I shouldn't have erased that, but we did. Okay? Well, let's just redraw it, just so the tail to tip method, you can see how the tail to tip method connects to the component method. And we're gonna call it A, vector A, vector B, and vector C, right? That's how they look, right? Huh?
Yes.
So, if we do the tail to tip method, tail to tip method, right? This is the component method. And how does the tail to tip method work?
Don't we have to when you add the tail to the tip? Like you use
We have to say it. We have to say it. We have to say it, folks. You got to learn how to talk this stuff. I'm telling you, it's good. It's gonna seem, if you just don't, and if you just look at it when you come here, it's not gonna be enough. You're gonna forget things. When you get on the test, and you're under pressure, you're gonna forget things. Things are gonna come to you slower. It's just not good practice, right? So, but we have to learn how to speak this stuff, okay? And the tail to tip method is exactly what it says it is, right? We take the tail and we put it to the tip of another vector. That's it. It's the tail to tip method, okay? So, I'm gonna redraw my coordinate system here. Right? And we said our resultant vector, let's call it just R, resultant is what? A plus B plus C, right? Right? Okay? So I start with A, and I write A right here. I always start from the origin, right? Because the origin is where things start from. Okay? So that's my first vector A, right? So now what do?
You connect the
I connect the
tail of B to the tip of A.
yes, right? So here is B, right? So it would be right here, right? So I would do this. What? I would just go. Y'all saw that?
Yeah.
And so here I would be what? That's B. So let me. So now, right? That's B. And now what would I do? Same thing, right? So I'm gonna just draw it to scale so it can make more sense. My thing is not really drawing to scale that good, so B probably be more like that, right? And then, right, so this will, right, this is vector B. And then C is where? Going straight down, right? Right here. Right here, which would be right here. So I just take that and move it right here. That's C. Vector C. Now look what happens, right? So how do we make the polygon? Connecting the last vector to the to the origin or to the first vector. Connecting the tip of the last vector to the tail of the first vector. That's important. Not just to the first vector, to the tail of the first vector. Okay? So then if I do that, boom, right? And so, guess what this angle is right here? What y'all think that angle is?
From B to the.
From here to here. What did we?
60.
That was close, but you guessed that. Why did you guess it?
No, because it's 90, 60, 45.
You're guessing. You're guessing. You don't have to guess.
Oh.
But you were close.
Oh.
Listen. How were you close?
Oh, it would be 69.
69.
Okay.
You see? See how we don't really connect these things. We think that we just doing math just to be doing math. No. That angle you just connected with the component method.
Okay, it's all the same thing still?
Yes, it's the same thing. This just has numbers on it. This is just graphically, according to your eyes. But it should still make sense. And the fact that it comes up here, somewhere in between 0 and 90, that makes me confident that this is correct. So we have to learn how to connect the component method to the tail to tip method. They're the same thing. One just has trigonometric identities. The other one is just you using your eyes and common sense. That's it. And it should make sense. So like I said, if everything was drawn to scale, the length of this vector would be 53.7. That's if I was drawing it to scale. If I had a ruler and all that, and I was drawing each one according to, I made this one, according to this, right? According to its X and its Y components, right? Because on a grid, everything has what? Little equal spaces, right? That's why you're in New York City and everything is a grid in New York City, right? Anybody been in New York City? Right? That's why you can get around so easily in New York City, because everything is a grid. Okay? Right? Avenues run north and south, and streets run east and west. So that's why people will tell you, meet me at such and such avenue and such street. Okay? All right, so I need y'all to understand that, okay? Because that's what that's one of the major things we need to take away from this chapter, okay? And we will be assessed on this, okay? Connecting the component method with the tail to tip method, because there are two ways to handle vectors. And then we'll be out of here, okay? Then we'll start talking about projectile motion, right? Like motion along the X and the Y at the same time, okay? All right, so how much time we got? I think that's it, 12:40. I definitely don't have time for another one. All right, so did I assign some problems on mastering for this chapter yet? I did.
Yeah, it was due like,
It was
due like before we even
Oh, okay.
Started this, yeah, it was due the Sunday of spring break.
Okay. Do I need to reopen it?
If you
I mean, I already did it.
No.
Oh, yeah.
All right. All right. So I'll reopen it, and yeah, and we're gonna. I think we're gonna do projectile motion in this chapter too. Yeah, before we go to chapter 4. Yeah, so we're gonna get on that. We're gonna start working on that next time, and we're gonna have a few problems in that too. All right.
So what chapters are we gonna find? Are we stopping at chapter 4?
Oh no, we're gonna probably stop at about 6 or 7.
And what is our final?
I don't even know. I know we got about 4 weeks left, huh?
Yeah, because mine's like the first week of
My final is
April
April 9th.
9th.
Oh,
No.
really?
Actually, no, May. It's May.
Yeah, maybe May 9th. April 9th.